Dear students of class 10, how are you all? I hope that by the grace of Almighty Allah, all of you are fine and safe. I am also fine. Welcome all to our today's class. I am MD Asghar Khan, Senior Lecturer, Department of Mathematics, Milestone College. I also hope that, my dear students, you are studying well at home during this situation. Already we are at the end of secondary level. So, dear student, you need more attention and more serious on your study, because without proper learning of this step, your further education will be difficult for you. So, we need more serious than previous. Today I will discuss about your higher mathematics from chapter 10, binomial expansion. This chapter is very important for your exam. Almost every year creative question and MCQ question come in board exam. So this chapter is important for your exam, and from the beginning of this chapter you have to know what is binomial expression and how we can expand the binomial expression. Binomial expression is a algebraic expression with two terms, and this binomial expression we can expand by two ways. First one is Pascal triangle and second one is binomial theorem. Okay, now we can start our today's class. Okay, my dear student, our today topic is chapter 10, binomial expansion. Before binomial expansion, you have to know what is binomial term. Binomial term or binomial expression is the algebraic expression with two terms. As an example, this is binomial term. It has a two term. The degree or power of binomial term is 1. So this expansion is a plus b. If the degree of binomial term is 2, then a plus b whole square is equal to, this is binomial term, and this is the expansion of this binomial term, because already we have know the expansion of this binomial term. Okay, if the binomial term is a plus b whole cube, then a cube plus 3a square b plus 3a b square plus b cube. Okay, but this binomial term, the expansion of those binomial terms are known, because already we have applied this formula in algebraic expression. So the expansion of these binomial terms are known for all. Okay, but if any the degree is 4, 5, 6, 7, but for highest degree of binomial term, for the higher degree of binomial term, it is not easy to say, but this for the highest power or degree of binomial term, we can expand by the two ways. First one is Pascal triangle and second one is binomial theorem. Okay, now we want to discuss how we can expand the binomial term by using Pascal triangle and binomial theorem. Okay, now Pascal's triangle. Pascal triangle, and this process was first used by Blaise Pascal. That is why this method is called a Pascal's triangle. Okay, if the any binomial term, if the degree is 0 of binomial term, then we can start from 1. If n is equal to degree is 1, then it will be 1, this is 1 and this is also 1. If n is equal to 2, then it will be the summation of 1 and 1 is equal to 2. Here is 1 and this is 1. If n is equal to 3, then addition of 2, 1 and 2 is 3. Addition is 2 and 1 is 3. This is 1 and this is also 1. Okay. Now n is equal to 4 and the addition of this 4, addition of this 6, addition of this 4 and this is 1 and this is also 1. Okay. Now n is equal to 5. Then addition of this is 5, addition of this is 10, addition of this is 10, addition of this is 5 and this is 1 and this is 1. And we can construct for n is equal to 6 and continue if we want any term, any value of n. Okay. If n is equal to 0, then this is 1 and 1 is the coefficient of a binomial expansion. If n is equal to 1, then this is coefficient. If n is equal to 2, and this is the coefficient of binomial expansion. Then for example, for n is equal to 3, then we get, for n is equal to 3, we get a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Here the coefficient of this expansion are 1, 3, 3 and 1 and 1. So here the Pascal triangle coefficient for 3 is equal to 1, 3, 3 and 1. 1, 3, 3 and 1. So Pascal triangle gives us the coefficient of binomial expansion, is term of binomial expansion. Okay, and then we can use this coefficient in binomial term, then we can easily expand of any binomial term. Okay, now how we can this coefficient by the binomial theorem. Okay, for the binomial theorem, here for n is equal to 5, the coefficient is 1, 5, 10, 10, 5 and 1 and 4, 3, 2, 1 and 0. Already we have got the coefficient. Okay, now for the binomial theorem, if just for example n is equal to 5, our coefficient is 1, 5, 10, 10, 5, 1. And how we can get the coefficient in binomial theorem? Okay, now by binomial theorem. Okay, how we can get the coefficient in binomial theorem? Okay, just example, for n is equal to 5, our coefficient is 1, 5, 10, 10, 5 and 1. We can verify this coefficient by binomial theorem. Okay, now we can use this symbol n r is equal to factorial n minus r and factorial r. Okay, and we can or this symbol we can write it in another way, n c r, where n is the highest, n is the degree of binomial term, r is related to that related to terms. Okay, here this also is factorial n or factorial n minus r in r factorial. We can use any sample in this or this. Okay, and how we can express for n is equal to 5. If n is equal to 5, then for 1 according to the binomial theorem, how we can coefficient is 1. Okay, then here n is equal to 5, so 5 0 or 5 C0 is equal to 1. We can get this value from your calculator or by this method. Here for n1 or 5C1 is equal to 5 by this method. Okay, if 5 2 is equal to or 5CR 5C2, okay, is equal to by this method, this is factorial 5 and minus of this factorial 3 and factorial 2, and this value is will be okay, we can express this term by this way. Here is 2, so 5 is, we can write 5, this is 5 into 4 and here is 2, so 1 into 2. Okay, we can, this is equal to this. Okay, so here is equal to 2 is equal to 10. Here this is 10 for 5C0 is equal to 1, this coefficient, 5C1 this is 5 second term coefficient, and 5 2 this is third term coefficient. Okay, how we can use Pascal triangle and binomial theorem in to expand binomial term, and we want to discuss this in your exercise 10.1 and 10.2. Okay, dear students, from 10.1 question number 2, according to the ascending power of x, expand the following up to the first 4 terms: 1 plus 4x whole to the power 6 and 1 minus 3x whole to the power 7. And this maths we can apply the any one Pascal triangle or binomial theorem, but we want to discuss by 2 ways, that means Pascal's triangle and binomial theorem. Okay, how we can expand this term by Pascal's triangle? Okay, for here n is equal to 6. Okay, here for n is equal to 6, then what will be the coefficient? At first we want to find by the Pascal's triangle. Okay, here n is equal to, for this term here n is equal to 6, so for n is equal to 6, the Pascal's triangle for n is equal to 0, it is 1. Okay, for n is equal to 1, and we have to find for n is equal to 0 to 6. So we need from, if for coefficient of for n is equal to 6, then we have to maintain from n is equal to 0 to 6. Okay, here this is 1 and this is also 1, and n is equal to 2, then addition of this is 2 and this is 1 and this is also 1. If n is equal to 3, then addition of 2 is 3, addition of 2 and 1 is 3, this is 1 and this is 1. N is equal to 4, then addition of this 4, addition of this 6, addition of this 4, and this is 1, this is also 1. Okay, n is equal to 5, addition of this 5, addition of this 10, addition of this 10, addition of this 5, 1 and 1. Okay, for n is equal to 6. So addition of 1 and 5 is 6, addition of 5 and 10 is 15, and addition of this 20, this 15, this 6, and this is 1, and this is also 1. Okay, already we have got the coefficient for n is equal to 6, 1, 6, 15, 20, 15, 6 and 1. So how we can expand this for n is equal, how we can expand this by using this coefficient. Okay, here no need for n is equal to 0 to 5, only we need n is equal to 6. Okay, okay, now 1 plus 4x to the power 6. Here we want to expand up to first 4 terms, up to first 4 terms. Okay, just so we want to use first 4 coefficient, we need first 4 coefficient. Okay, first coefficient is 1 and this is 4x. The power of second term, you have to maintain ascending order. You have to maintain the ascending power of x. So the second term, the power of second term maintain ascending order, and first term you have to maintain descending order. But here first term is 1, no need to mention it. Okay, so from 1, here 4x 0, ascending power start from 0, and here is 6. Okay, first coefficient is 1 and term is 4x to the power 0, and second coefficient is 6 and power of then term is 4x. The term is 4x 1. Okay, and for this is 15 and this is 15, then 4x 1 and plus, and last one is 20 this is 2 and this is 3. Okay, and dot dot, because we have another terms, but no need for another term because our question need first 4 terms. Okay, so here first term, second term, third term and 4 terms. Okay, and the calculation of this is this is 1, so answer is 1, and this is 24x, and this is 16 into, here this is 4, and square of 4 is equal to 16 into 15, (240). So it will be 240 x square plus 4 cube is equal to 64 into 20, 1280 x cube. Okay, my dear student, this is our expansion up to the first term by using Pascal's triangle. Okay, now this expansion we want to expand by binomial theorem. Okay, how we can apply the binomial theorem? Okay, now for the binomial theorem, for theorem. Okay, how we can expand this by using binomial theorem. Okay, here 1 plus 4x to the power 6 is equal to 1 plus 4x to the power 6. So first term, the coefficient first term is here n is equal to 6 c r. Here r is equal to the position of first term. For the position of first term it will be 0. Okay, then 4x 0, and for the second term 6c1, then this power will be 4x1, because ascending power, the power of second term always ascending power and first term is according to descending order. Okay, so and 6c2 4x square and 6c3 4x cube, and okay, dot dot. Here first term, second term, third term and fourth term, we need fourth term. So 6 is 0, always 1, because nc 0. Just you have to remember nc 0 is equal to always 1. nc 0 is always 1. It may be 5c0, 6c0, 7c0, 8c0, and also another one is ncn is also 1. Okay, so 6 is 0, it will be 1. So 1 plus 4x to the power 6 is equal to, this is 1 plus, and 61, always it also you have to remember nc1 is equal to n. Okay, so 61 is equal to 6, 7c1 is equal to 7, and so into 4x plus 6c2. How we can express 6c2? Here is 6, this is 2, so 6 we can write 6 into for 5, and here is 2, 1 into 2, 6c2. For 2, here is 2, so we can write 6 and 5, 6 descend from descending way, we can write 2 number 6 and 5, and 2 is equal to 1 into 2. Okay, so 16 x square, and plus for 63, this number is 3, so we can write 6, 5 and 4, and here this is 3, it will be 1 into 2 into 3, and 4 cube is equal to 64 x cube. Okay, plus dot dot. Okay, here 1 plus 6 into 4, 24x, and here this is 3, so 3 into 5, 15 into 16, 15 into 16 is equal to 240 x square, and here this is 2, and so 20 into 64, 1 2 8 0 x cube. Okay, so by Pascal triangle and binomial theorem, both expansion are equal. Both expansion are equal. Okay, so any term, any binomial term, this is our result of this expansion up to the first 4 term. Okay, we can expand any term by using Pascal triangle or binomial theorem, but the Pascal triangle, it has a limitation. If the power is just say is the power is 20 and is equal to 20, so it is not easy to draw the Pascal triangle. But for the any power of the binomial term, we can use binomial theorem.